Good day everyone! I'm Juliana and I will be your math teacher for today. To give you an idea for today's lesson, you will play a game called 4 Picks, 1 Word. Are you excited? Great! I will show you 4 picks each slide and you will be given 5 seconds to guess the words that corresponds those pictures. Are you ready? Let's now begin!
For the first slide, what do you think is the answer? The answer is measure. How about for the second slide? The answer is position. Next is the answer is divide. For the fourth one, the answer is distribution. Next, the answer is 100. And next, the answer is equal. And for the last one, the answer is parts.
Measure, position, divide, distribution, 100, equal, and parts. And it will become the measure of position that divides a distribution into 100 equal parts. And that's the meaning of percentile.
You have learned already about finding the mean and the variance of the sampling distribution of the sample means, and now our new topic is about percentile and t-distribution. After going through this lesson, you are expected to illustrate the t-distribution and identify the percentile using the t-table. And now, I will introduce to you the t-table, which you can use to find the t-value. So, we need to be familiarized also the uses of this table. Here, in the left side, the 1, 2, 3, up to 30, that is what we call the degrees of freedom. And the 0.40 up to 0.005 here at the top, that is the area. Area in the right field of distribution. And the numbers inside it, that is what we call t-values. Before we discuss percentiles and t-distribution, let's be familiarized with these words. First, degree of freedom. This refers to the maximum number of logically independent values which vary in the data sample. Second, percentile. This is a measure of position with data divided into 100 parts. Okay, so let's recall the uses of the t-distribution. T-distribution is used for the following reasons. Number 1, when the population standard deviation is unknown. Number 2, the sample size is less than 30. So we have here our first example. Identify the t-value whose number of samples is equal to 7 and has an area equal to 0.05. N is equal to 7 and area of 0.05. To identify the t-value, Identify first the degree of freedom using the formula. Degree of freedom is equal to n minus 1, where n is the sample size. Our sample size is 7, so minus 1 is equal to 6. Locate the t-value on the t-table using the degree of freedom and the area. Our degree of freedom is equal to 6 and our area is equal to 0.05. Therefore, the t-value with sample size of 7 and has an area equal to 0.05 is 1.943. For our second example, identify the t-value whose number of samples is equal to 17 and has an area that is equal to 0.005. Our sample size is equal to 17 and our area is equal to 0.005. Again, to identify the t-value, identify first the degree of freedom using the formula. Degree of freedom is equal to n minus 1, where n is the sample size. Our sample size is 17, so minus 1 is equal to 16. Locate the t-value on the t-table using the degree of freedom and the area. Our degree of freedom is equal to 16 and our area is equal to 0.005. Therefore, the t-value is 2.92078, and if you round off it in 3 decimal places, it will be 2.921. For our third example, find the t-value whose degree of freedom is 20 and has an area that is equal to 0.01. Since the degree of freedom and area are already given, locate the t-value on the t-table. Therefore, the t-value with sample size of 20 and has an area of 0.01 is 2.528. For our last example, the 95th percentile is the number where 95% of the values lie below it.